Hello and welcome to Technical Utkranti. And today we'll see the question based on rotating the matrix by 90 degrees. So these are the questions that we have done, and today we'll see rotate matrix by 90 degrees. So let's see what this question is. Let's suppose there is a 4 cross 4 matrix and you have to rotate it by 90 degrees, which means that this row becomes this column, this row becomes this column, and so on. Do not confuse it with transposing, because in there row 0 becomes column 0, row 1 becomes column 1, like that. Here it is not the case. Here row 0 is becoming column 4, right? Okay. So the solution lies in the fact that first the outer edge has to be rotated and then the inner edge has to be rotated. Okay. So if the length of the square matrix is 4, then we have to carry out two such rotations. So the number of rotations is half the length of the square matrix. Okay. Now what has to be done is basically this element is replaced by this element. So 0 comma 0 is replaced by 3 comma 0. 1 comma 0 replaced by 3 comma 1. 2 comma 0 is replaced by 3 comma 2, right? Similarly, 3 comma 0, which is this, is replaced by 3 comma 3. This is replaced by this is replaced by this, and then so on. All these calculations are done. As you can see, in this particular thing, the column remains constant. As you can see, when we are traversing over here, column will remain constant, and whatever it is replaced with, there the row remains constant to 3. Similarly, this where row remains constant is replaced by the column constant 3, like this value, right? Similarly, this is replaced by this where row remains constant to 0, and this is replaced by this where column remains constant to 0. This is clear. This is the replacement of the outer circle, right? Let's see this in the code. So here the outer loop makes sure that the number of rotations is half the length of the matrix. We'll understand this what it is. Firstly, we'll see these instructions. So this is where the rotation is beginning. As you can see, in the first category, column remains constant. Wherever the constant thing is there, the outer loop will be there, because in the inner loop, outer loop value, which is I, will remain constant. So in first iteration, I equals to 0. So this will remain 0, right? And j will keep on changing. So j will go from 0 to uh, 0, 1, 2, right? So as you can see, this value will be 0 comma 0, 1 comma 0, 2 comma 0, and this is where the row will remain constant, and it will be like 3 comma 0, 3 comma 1, 3 comma 2. All right, fine. Okay, now this is the exchange of the outer boundary, right? Whatever the code that is written over here for this particular exchange should work for this, like this exchange over here, right? So currently we have written the code for this exchange, which should work for this exchange in the inner loop. So for the inner loop, like over here we are starting from 0, 0. In the inner loop we'll be starting from 1 comma 1, right? That's why this I is coming here. So in the next iteration, I will be equal to 1, and this constant part wherever we have put I, this will take care that now the starting point is 1 comma 1, right? So J is also starting from I. All right. So as you can see in the diagram over here, for the first exchange, the span is very big, but in the next thing, the span is small. Okay. So as we know that the number of rotations are just half the length of the matrix. So this takes care of one of the coordinates. So there are two coordinates, right? X and Y. If my I is only travel like ranging from 0 to n by 2, and I is appearing in one of the coordinates in over here, right? Sometimes it comes up as a column, sometimes it comes up as a row. So I's range from n by 2 takes care of the fact that in subsequent iterations, the value of either row or column is getting squeezed up, right? Now, as you can see, the value of j is also ranging from I to something minus I, right? So as the value of I increases, the value of like the span or the range of j is also reducing. This takes care of the other coordinate, right? So if I is taking care of column over here, j is taking care of row over here, right? For example, for the first iteration I was 0 and j was allowed to roam between 0, 1, 2. But as soon as I was increased to 1, j could only be 1, which is like 1 to 2, which means that it can only be 1. All right. So this code is, I mean, this code can be a little sophisticated to understand, but what the first point was that wherever you see at either the column constant or the row constant, the constant part wherever it is coming up, there the outer loop variable will be there, because outer loop does not change at each iteration of the inner loop, right? And then what needs to be remembered is that once uh, the outer edge is done, we come to the inner edge, and here the coordinate range of both the horizontal and vertical coordinates is squeezing up, right? So one of the squeezing up is taken care by I being in the range of n by 2, which is length of the matrix by 2, and then j being in the range of I to length of matrix minus I. So both are getting squeezed in the next iteration of the outer loop. Okay, so that's it. Now wherever we see that the reduction is happening from the bigger the length of the matrix, so there we'll put last lm minus I. Okay, now somewhere you will find last lm minus j. It is because this, I mean, this is changing. All right, and wherever it remains constant, it is last lm minus I. All right, so this is very straightforward thing. All right, I mean, if you don't understand, it could be complicated, but there are only few things that need to be remembered. What needs to be remembered is that firstly you made this matrix and you see that whatever that remains constant, there I will come. Now if it is 0, then in the code it would be simply I. All right, wherever it is changing from a higher value, then there will be last lm minus j. Okay, wherever it is increasing from a small value, then it will be simply j. So yeah, that's how it is. Okay, because and this kind of code will take care of the outer edge changes and the inner edge changes both. So yeah, just go through this code and see. If you don't understand, you can drop in the comment. All right, so after rotation, we'll just print both the matrices and see. So I have printed the matrix before rotation and after rotation. So let's see. So as you can see, 1, 2, 3, 4 has come here, 5, 6, 7, 8 has come here, 9, 10, 11, 12 has come up here. Okay, maybe I can have, yeah, 1, 5, 9, 13 has moved here, 13, 9, 5, 1, like that. So yeah, this is how matrix rotation is done. Uh, yeah, that's it. That's it. There are few lessons learned over here. So this kind of matrix operations are used in image processing, and yeah. So what was the important thing to learn over here is how we visited the edges, outer edges and the inner edge, and then subsequent inner edge one by one. So this is something important to understand, right? So thank you, and yeah, bye bye.